So let's start out with types of variables. In a good experiment, there are 3 types of variables. We have our independent, dependent, and standardized variables. Starting with the independent variable. The independent variable is kind of what it sounds like. It's the variable that is not dependent on any other variable in your experiment, right? And so this is something, the data that stands alone. It isn't changed by other variables that you are trying to measure. Sometimes that means that the independent variable is what's manipulated by the researcher, okay? And every experiment should only have one independent variable, ideally, because you should only be looking at one thing at a time in a well-designed experiment, okay? Moving on to dependent variables. Dependent variables are what you hypothesize to change when the independent variable changes. Right? This makes sense. This is where it gets its name from. A dependent variable is dependent on the independent variable. It's what is observed and measured. It's how you collect your data, or what you collect your data from. Sound good? Something that's really important to note, though, about both of your independent and dependent variables is that you measure your units very carefully and that you label what units you used when taking note of your methods in your study as well as your results. So when you're reporting on your experiment as well as designing your experiment, noting how things are measured and the units that you used, such as grams versus meters versus liters, is very, very important. And now finally, last but not least, are standardized variables. These poor guys often get overlooked, but they are so important, just as important as a dependent or independent variable, because without standardized variables, your experiment might not elicit proper results. Standardized variables are the variables that researchers standardize or keep the exact same in all of their groups, right? So making sure that we are controlling for certain things so that way we're only testing the relationship between the independent and dependent variables. The reason why standardized variables are so important is because they help avoid confounding variables. Remember, we really only want one thing to be different between each of our experimental groups, and so that thing is usually the independent variable, what we are studying, the treatment. This is why having standardized variables is so important. So with that out of the way, let's go ahead and look at an example to make sure we understand. Charles' law states that as temperature increases, the volume of gas expands, and conversely, as temperature decreases, the volume of gas decreases. You design an experiment to explore Charles' law. What would be the independent variable? What would be the dependent? And then what would be the standardized variables? Pause the video, take some time. Okay, now checking back in, what would be the independent variable? In this example, our independent variable would be temperature, because temperature is not related to anything or dependent on anything else in this experimental design. In fact, the volume of gas is dependent on the temperature. So off the bat, we know that temperature, which we are increasing, right, or decreasing as part of our experiment, so it's manipulated by the researcher, the volume of gas is dependent on temperature. So temperature is our independent variable, and volume of gas is our dependent variable. And then standardized variables, there are a lot of options for this. One of them could maybe be the apparatus that you used, making sure that you're using the same equipment across the board when you're repeating your experiment and gathering more results, more data points. Maybe the amount of sunlight that's exposed. You never know if something is in sunlight, maybe it's swaying your temperature a little more than you would have thought. Or measurement devices used, making sure that you're measuring using the same things across the board to make sure that you're avoiding those confounding variables. Just a couple examples. Sound good? Okay, let's move on to your next check-in. Check-in number 5. Jamie is conducting an experiment to help answer the research question, does age impact weight loss? Jamie gathers a sample size of 100 voluntary participants of varying ages for their experiment. To minimize confounding variables in their study, Jamie has all participants live in the same type of housing, follow the same diet plan, and all undergo the same exercise regimen for 1 month. From this information, determine what is or are the independent variables in Jamie's experiment. What about dependent variables? And what are the standardized variables? Moving on to check-in number 6, making sure that this is number 6 that you are looking at. Is anything ever proven in science? So that's looking at variables.